Hey guys, welcome back to my channel and also welcome to the Gemini era of Google guys. Google recently launched its Gemini AI capability and we all have been getting so crazy over it because it is one of the major AI breakthroughs in the software industry. And in this video guys, we are going to discuss a little bit about Gemini and we will also build our own custom Gemini like AI bot. So I hope you guys are really excited for this video. I am also excited to share with you guys what I have learned so far. So without wasting any time further, let's get started. So first of all guys, what is Gemini? So Gemini guys is a AI functionality that has been released by Google and that is comparable to the latest GPT Pro version. But the best part about Gemini is that it gives you the multimodality AI functionality, which basically means guys that this AI bot will accept your text, images, video, audio and your code data formats. That means that for now in chat gpt you are only querying through text, right? Like for example, write me a summary in 20-30 words, or in case of Google Bard, if you go, then you might be able to also in this way you can upload the image and that image could also be your prompt. But with Gemini guys, you will not be able to just do that. You will be able to give your text, images, video, audio and also code based data to get some inference out of it, some AI summarization or generative AI out of it. And now we have already seen guys that generative AI is becoming so enhanced that with generative AI you can even create images, you can even create music and text anyways you will be able to create. But with functionality like with power like Gemini, later I think you will also be able to do something like creating a full feature length movie with just AI. So Gemini definitely gives us a lot of really interesting stuff guys, and the best part to explore that stuff is to go into the Gemini's website, which I have right now in front of me, and here you can see all the capabilities that Google has mentioned. They have also compared Gemini Ultra with the GPT-4 version and how efficient it is, and you can see that almost at every paradigm Gemini Ultra is having much better performance in reasoning, in general, in math, in code as compared to GPT-4. Now in multimodality also you can see that if you see the capability of images, Gemini is better. If you see videos, Gemini is much better in find the real time analysis over a video, and then for audio as well. Now Gemini comes in three sizes guys: Ultra, Pro and Nano. So Nano is mostly for if you are using your Gemini on your small mobile devices. For example, if you are opening your Bard in your Google Bard in your mobile device, you will see the Nano functionality or Nano based power. The Pro model will be for maybe for your laptops or your desktops over a website that you can obviously see on my screen right now. But the Ultra model is not yet released guys. However, it is being said that Ultra is going to be the most capable and largest model, and it will be able to do the highly complex tasks which you can imagine. Now anything to anything. So basically guys, Gemini can generate code on any type of input. So you give it text, it will generate. You give it audio, it will generate something for you. Basically you give it anything. So you can see that here in this hands-on, somebody has given just an image. That can Gemini show me ideas on how to make anything out of this, these wool, and the Gemini is able to give it, right? Now somebody is giving them a music video of all the music being written, and Gemini is able to produce a song out of it. And somebody gave it a video, and now Gemini is creating a demo based on that video. So how cool is that guys? Gemini is able to generate a video from a video, generate an audio from an audio, basically generate anything from anything. And that is the power of Gemini guys. That is the real power of how you can use AI to completely change the software industry and change the lifestyle you are working with. If you want to have a hands-on demos, right, obviously you can see in the Gemini website there are a lot of hands-on demos. I will not be going through all of these, but obviously guys, So far whatever I have shown you, I think you guys realize the potential of Gemini, because until this point ChatGPT was able to create text based summaries out of text based prompts, right? But what Google Gemini is giving us is you can create any prompt. You can have a prompt of an image, prompt of a audio, prompt of a text or a video, and you can create or generate the answer also in any format. You can create a video out of it, audio out of it, text out of it, image out of it. Google Gemini will be powerful enough to do so. So that's the potential of Gemini, guys. But now that I know that you guys understand what Google Gemini is capable of, do you guys think I am able to make something like this? Well, I'm not so sure, but I'm going to try my best. What I'm going to do, guys, is I'm going to build my own multimodality based AI bot and show it to you how you can create your own as well. And let's get started with that. Okay, so before I start with the video, guys, you can obviously see that if you go to Google Bard, and you can just create and upload your image here, any image you want to see, you will be able to just hit the prompt and you can get some answer. So at the end of my video, guys, we will definitely compare the results of my own custom bot with Google Bard's bot, and we'll see who is gonna win. Let's get started now. So first thing first, guys, we are going to open a simple Visual Studio. So this is the Visual Studio that I currently have, and you can see I've got some images, some audio files, some videos in this project already, but these are just the inputs that I will be using to actually demo my application to you. You don't have to worry about that. If you don't have these right now, you don't really have to worry. You can upload your own images, your own videos, your own audio as the way you like it. But what you don't have right now is the actual code to actually produce this. So let's see how we can do that. Okay, so first thing first, guys, what you need is basically a set of Python packages, which I am going to create now in a file called as requirements.txt. So let's first create that. So this is your simple project, and in this simple project, first of all, you will paste all these requirements.txt. One more thing, guys, this entire project is actually uploaded on my GitHub, so you will be able to download the code from my GitHub public repository, which I will mention in the comment section below. So don't worry if you cannot follow the code right now, or if you want to refer it later, you will be able to do so with my GitHub as well. Okay, so now that we have got the requirements.txt created, you can see all these requirements. First is LangChain, because obviously we are going to use some LLM models to do our AI predictions. Then we have got Streamlit for our UI. Python.environment, this is also needed for your Streamlit UI, so that's why. PyTesseract, so guys, PyTesseract is a Python module which is used for analyzing images, and we are going to deal with multimodality here. So PyTesseract is used to actually extract the text out of the images, so that's why we have got PyTesseract. And with PyTesseract you also need a module called as Pillow, that's why it's that. OpenCV Python is used for video analysis, and obviously one of the modalities in our case is going to be a video, so that's why OpenCV. Transformers, guys, is used for your pre-trained AI model. With in our case, we are going to use pre-trained AI models from Hugging Face. So for that, we would use transformers. And Librosa is also being used with transformers. But what Librosa is mainly associated with is audio files. So we are going to use audio transcription because we have an audio input as well. That's why we would need Librosa. So now that you know why I need all these packages, and you have all these in your requirements.txt, let's get started with our first Python file. Okay, so let me just go here and let's create a new file, and let's call this app.py. Okay, now in this app.py, guys, what we are going to first of all do is do some imports. Okay, let's do some imports, and these are the imports which I am going to just copy paste here, And don't worry about it if you don't know much about it. I'm going to explain all the imports one by one. So first of all, I'm going to import Streamlit, obviously, because we need a UI application. Then there is a bytes.io. So when we are using multimodality data, guys, for example images, for example audio or video, this data is going to be in bytes, right? And you need a class to actually handle this bytes data. So for that we would need bytes.io. Obviously we have an image which we need to analyze to. We are going to use PyTesseract. And PIL is also for image library. CV2 is for your video analysis. Librosa is for your audio, and Torch is also for handling this multimodality behavior. So that you would need Torch. Now you would need prompt template and LLM chain if you want to do stuff with your AI. Later we won't be using prompt template in this, but however I will I have still placed that in import for some reason, so you can ignore that. But yeah, rest of the imports, transformers and the wave 2 vec2 for CTC and wave 2 vec2 tokenizer. This import, guys, is mainly for your audio transcription. So these are the two models. So wave 2 vec2 is actually a Hugging Face model which we have used to actually do audio transcription for us. And auto model for CQM and auto tokenizer pipeline. These three things are basically for our Hugging Face model which we are using for prediction. So in our case, guys, we are going to use a Google FLAN model, and that FLAN model is basically going to take your prompt and it is going to give you some answer on the basis of it. So for example, you can give it a prompt like anything like what is democracy or anything like that. So that prompt will be given to your Google FLAN model, and FLAN model then is going to answer your question. And because we are using Hugging Face pipeline, guys, we are going to use Hugging Face, because we are using Hugging Face models, Hugging Face pipeline is here. So these are some of the imports. But last but not the least, guys, one of the import is HTML templates. So what we are going to do, guys, we are going to actually design a UI for it, right? And that UI is going to have basically a placeholder. Actually, I have already built this bot in a previous project. So let me just show you the basic of it, how this is going to look like. So this is going to be the bot which we are going to build, and you can see that what we basically need is first a file that we are going to upload. Now that file could be any type of file, any type of data, image, audio, video, etc. So we need a file uploader, and we need then some place to actually answer our questions, make it like a chat environment. However, to design this entire thing, you can see the headers, the file uploader, etc. We need an HTML template, right? So what I have done here is I have actually imported an HTML template to actually make our UI a little bit better. Now this HTML templates file, guys, we actually have to create this file. So let me just copy this and let's create a new file called as HTML templates.py. Okay. Now in this HTML templates.py, I'm going to just copy paste the CSS that I have already created for this demo. But this is a very basic CSS, guys. So this, if we start from the beginning, this is just some styling tags. And then we have got our bot template, which is nothing but a div that is going to display you the answer that was given by the bot. And then you have got your user template, which is again a div that will show you the answer, that will show you the question that was asked by the user. Okay. So that's your HTML template.py, and now we have imported it, and you can see now the error has disappeared from app.py, which was basically, the HTML templates.py file was not created. That's why the error was coming. Okay. So now that we have this app.py and we have got our CSS and everything there, let's start to write some code. Okay. So first thing first, guys, we are going to write a main function. Let's write nothing into it, and then we will just say that whenever the app.py file is instantiated, then we are going to just call the main function. Okay, so that is going to be our basic thing for now, and let's do this step by step, and then we will also run this code one by one just to see that we are on the right track, right? Now how do you run this code, guys? To run this app.py file, there is going to be a very simple command, and that is python -m streamlit run and then app.py. So once you run this command, guys, you will be able to actually run this code, and you will be able to see. So yeah, there you go. You can see that the code has now running in the running status, and once the code finishes running, you will see nothing getting appeared for now, because we haven't actually placed any item on the UI yet. Our main function is basically not returning anything. Okay, so for now you can see that nothing gets returned. This is a very blank page, so we don't want that. So let's start writing something into it. So the first thing which I want to write, guys, is a sort of a header. Now that header is that this is an answer to my multimodality to the Gemini bot. So what I'm going to do is I'm going to do st.write my answer to Gemini multimodality bot. Okay, now good thing about Streamlit is, guys, that if you do any sort of change, you can actually see it getting reflected on the page without actually killing your job and restarting it. But I will still restart it for now, but now from now onwards, whenever we will make a change, we will not be restarting it. Okay, so now you can see that once you made a code change, and you just you don't have to restart it. Once you just make a code change, you just refresh this page, and you will be actually able to see the output. So it's a bit slow, guys, and that's because of my system. But now you can see the header that I have added have now appeared. Not only this, guys, I am also going to set a title to this. So to set a title to your page, to your Streamlit page, the command is set page config, and you can just add the page title, and you can even add a page icon if you want to. Now what I will also do is I will also style this a bit. So I will also create this CSS, which with the CSS that we imported from our HTML templates.py. I have also made that CSS part of my Streamlit HTML page. Okay. So now this is the thing, that you have got your your page is there, and your page is able to display some things. Now what we want is actually a file uploader. Okay, now if you just want to add a file uploader, guys, then the command for that is simply st.fileuploader. So once I do, uploaded file becomes equals to st.fileuploader, and whatever you write here. And now once I simply refresh my page, this should be able to actually render a file uploader now. So it's running, and now you can see that at least the UI part of it is a bit done, because we are able to give our heading, our title, and we are able to give a file uploader, right? So now what we want to do is, first thing is that whenever you are going to upload a file, you don't know which modality that file is, right? The first step should not be like, okay, I want to parse the image, or I want to get something out of the video. No, the first thing should be to understand the input type. So for us, we want to first find out the extension of the file. Okay, so let's see, this is my uploaded file. Okay, and let's say that the by default extension, let's store the extension of the file in a variable called as extension, and let's say by default the extension is unknown. Okay, now this is a particular code that I'm going to write, where this is not just, this is just saying that if the uploaded file is not none, so that means if a file has been uploaded, check the value of the file. So the value of the file will go into the bytes data. Actually, you don't need the bytes data. what we want to basically check is what is the extension of the file. Okay, that's what we want to check. So if the file name ends with txt, it means the extension is txt. File name ends with wave, it means it's an audio. If the file name ends with mp4, it's a video. And if a file name ends with jpg, it's an image. Other than that, we don't support any other modality. We don't support any other modality. Okay. Now you can also see in this code that once we have assigned the extension, we are also setting a session state. Session state is that the session state or value preview is going to be set to it is a text. In preview, if it's an audio, then the preview will be it's an audio, it's a video, it's an image, right? Now we don't really need this session state preview to be set, but what we want to do is we want to basically display what type of file has been uploaded, right? So what we can do is we can create a text area. So just after this if else statement, we can actually create a text area in Streamlit, and we can place the key of that text area as preview. So whenever the preview value is going to be set, so once the session state preview is set, this preview state is going to display displayed in this text area. Okay, so actually let's add this a bit before, let's add it here. So once you have rendered your file uploader, we will also render our text area, and whenever your file is being uploaded, it will check the extension and it will make sure that the session state of preview gets set to that, and the session state preview is now going to be displayed in this text area. Okay, so let's simply just give it a check that if the extension checking is working for us or not. So I'm going to click on browse file. Okay, it's still running, so let's wait until this is running. So you can see that for now the file preview is empty, right? So once I browse it, and let's say I click on an audio and I click on upload, and it is giving me an error that cannot be modified after the widget with the key preview is instantiated. Okay, so I think it is because our session state is not actually set. So let's just set that first. Okay, give me a moment. Actually we don't need this session state, right? So let's just delete this. Let's just simply print, print it's a text, and similarly let's print it's an audio. And because we don't really need a file preview, guys, we just need to first know that which extension is this. So just for debugging purpose I added this this file preview one, but we don't need to waste time on this. We can just simply print on our Visual Studio command prompt and see what type of extension that particular file is, right? So let's delete this code. Okay, let's open this again, and this time when we will upload a file, we will simply just check the command prompt and see that which type of file is this. So hold on, there you go. Now the file preview has been removed. I click on audio, I click on open, and let's see our Visual Studio now. So you can see that I uploaded an audio, and the Visual Studio correctly prints that the file which has been uploaded is an audio, right? So that's the first part of our project. The first part is to understand which input it is. Now when we know which input it is time for us to handle that input. It is time for us to understand how we can actually process that input and we can get some inference out of it. Okay, so in our case, guys, obviously we cannot compete with something like Google Gemini because it has been created with a lot of resources and a lot of supercomputers. We don't have that. But what we are going to do in our case is we are going to actually extract text out of the input. So for example, if this is an image, we will extract the text out of the image. If it's a video, we are going to text extraction out of every single frame in the video. If it's an audio, we will we will do the speech to text. And if it's a text input, we are just going to take the textual data and use that as an input, right? So in our case, we are essentially doing text analysis also, but we are just extracting the text from a different types of input, okay? So now that we know how we are going to process our input, it is time for us to actually write a handle input function, okay? So let me just first create a handle input function, okay? And let's copy and paste some code that I have previously written, but don't worry about it. I will again explain you the code in detail, okay? So this is a handle input function, guys. Let me put this here, just a moment. Okay, let me copy paste it here. Okay, and now let me explain you what this handle input function is actually doing, okay? And this function is also calling actually one helper function, which also I am going to create here, okay? Now let's go with handle input function one by one. So you can see the arguments this handle input function is taking. The first argument the handle input function is taking is data, okay? So whatever data is there in your file, in your uploaded file, that data you are going to pass in this handle input function, okay? The second input is going to be your extension, because we also need to find out which type of file is it. Is it an audio file, is it a video file, etc, etc. So that extension variable that we just created in our main function, that is going to be passed in this handle input function. The next thing is going to be a tokenizer and a model. So for some of the modalities in this case guide, we need a model and tokenizer to actually do the input text extraction for us, okay? And by that I basically mean the audio transcription. So for audio transcription, we are using a Hugging Face model. So for that, we are passing a tokenizer and model, and that tokenizer model is basically for audio extraction, okay? Probably would have named it a bit better, but for now it is what it is. You can mainly maybe name it as audio tokenizer or audio model, okay? But for now I'll just keep it as is, okay? So first thing first guys, we just created a variable called as extracted text, and that variable is the one which we are going to eventually return from the handle input function. The handle input function is doing nothing, but it is parsing your input, finding the text extraction, and then just returning it. So that's why this extracted text is eventually going to be the return variable of this function, okay? So the first thing first, if the extension is text, so that is pretty straightforward guys, because obviously our uploaded file data is going to be in bytes. So if you want to just convert the data from bytes to string, you can just do data.decode UTF-8, and that will become your string data, okay? So if it's a text file, it's very simple. You just do decoding into UTF-8 and you will get your string data, okay? If the extension is audio, now I told you guys that for audio we are actually doing a little bit of audio transcription using Hugging Face model. There are other speech recognition module in Python as well, although they did not work for me that well. Their accuracy was not so good, so that's why I found one model which was pretty good, and that's what model I'm actually using. So before I start with the audio part guys, let me just first show you something about that model which I am using. So the one thing is that where2 vec2, so that's the model guys, and don't worry about it. Again, I will place a link of this model also in the description below, so you will be able to easily find it. So what I did guys is that I used this entire model, and I actually downloaded this model, all the files of this model on my local system, and when I downloaded them, then I was able to use them locally. However, if you don't download them, if you just use same code that I have got on GitHub, then you will not have any error, because your system will simply start to download them from the internet. Okay, but I wanted a little bit of better performance, so that was the reason that I simply just downloaded this model on my local machine. So I was able to I was able to use it a bit quickly. Okay, and by the time I have been talking to you guys, I also have copied the same model on our project as well. So you can see that the same model files that I was just showing you on Hugging Face website, I have downloaded them and I have placed them in the Facebook Wave to Web 2 directory. Okay, so now that you have you have the model with you, so first thing first is that we have a bytes file. Okay, now because you have got the file in bytes, and our model actually just takes the file path and it processes it, so it needs a file path. So for that reason, I am actually creating the temporary audio file, and I am just writing the bytes that we have from our uploaded file into the temporary audio file. So this write bytes to IO function is doing nothing, but it's just taking the bytes from the uploaded file and copy pasting into this temp audio.wave file, and that's all it's doing. Okay, so now that we have the file saved, then this /temp audio.wave will actually become the path of my file. Okay, now this file needs to be uploaded by the Librosa library. So once you have got loaded, once you have got this librosa.load file, then this will give you actually two things. First thing, audio, and also the rate of the audio. Okay, so we don't really have to do anything with rate, but we do need the audio, and this audio is now going to be fed into the tokenizer and the model. Now you guys might say, where is this tokenizer and model coming from? Because I only have the model downloaded it here, but nowhere I actually created the tokenizer model object, and I actually passed it here, right? But don't worry about it, guys. We are going to create the object of tokenizer and model from this wave to web to model only, and then we are going to pass it in this handle input function through our main function. Okay, so don't worry, we will actually create this tokenizer and model variables in the main function. Okay, a little bit later, but for now just understand that the tokenizer is actually just taking your audio, converting it into tokens, and then finally those tokens, which have now become our input values, will go into our model. Okay, the model will get some logits. The torch, which is our PyTorch, is going to find out the maximum argument of those logits. So basically the highest ever prediction or the best prediction, right? And that will be our prediction finally. And that prediction is actually our transcription of audio. Okay, so let's say your audio is saying something, you have some speech, and now you have transcribed it. Now you just place that transcription into your extracted text variable, and that extracted text variable just gets returned to you, and that's how we are processing an audio. Okay, so simply taking a tokenizer, taking a wave to web to model, and then doing a bunch of steps, and finally your tokenizer.batch decode will decode that prediction, and whichever is the best prediction, that's in the zeroth, the first index, and that will be your extracted text. Okay, I know it's a little bit confusing, I know it's a lot of stress, but once you understand the basic, then you will be able to understand what's happening. Okay, so just think about it in that way, that you could have used any library for speech to text, but in our case we are using a model to do audio transcription. If you have a better way to do speech to text, if you want to do it in a different way, that's up to you. You can obviously replace this code, but just remember that our goal is to just extract the text from the audio. Okay, and you can do it in whichever manner you want. The next thing is your image. Now for image, there are only two lines of code because we are just using image.open bytes IO data, and then pytesseract image to string. Although there are only 2 lines of code written here, there were a bunch of steps that were done to actually achieve these 2 lines of code. And I'm going to explain you those steps as well. So the first thing first, guys, I told you that we need pytesseract to actually do image text extraction. So what the thing is that just by pip install pytesseract, you will not be able to so just with pip install pytesseract, you would not be able to do this step. Okay, what you also have to do is you have to download the tesseract exe file. Okay, so if you just go to the tesseract documentation, and I actually downloaded the exe file from somewhere. Downloads for, okay, yeah, let's go to the releases. Here you go. And okay, I'm going to find out the exe file for you. 1 second. Oh yeah, I think it's this one. Yeah. So sorry about this, guys. I'm just trying to find out from where I downloaded the exe file, but you don't have to worry about it, guys. I will find it eventually, and don't worry, I will put the link in the description below from where I downloaded the file. But basically, guys, what I did is that in my program files, you will see that I downloaded the tesseract module, and I'll show you in my program files. So basically from the internet I have downloaded the tesseract OCR modules. If you just maybe just Google tesseract OCR, you will be able to get this exe file, and once you run this exe file, you will be able to get a bunch of files installed in your program files, right? And this is really important. This is like the prerequisite for using pytesseract. If you don't have tesseract OCR installed on your system, you will not be able to use pytesseract. Again, reiterating, I will put the link of downloading the tesseract exe in your in the description below, so don't worry about it. Okay, now what you also have to do is you have to actually go to your environment variables, which I will just show you in a moment. So you have to go to your environment variables, you have to go to your path, you have to edit it, and you can see that this path, program files tesseract OCR tesseract.exe. So basically the path of your tesseract.exe file, this path you have to add it in your environment variable. Okay, so when you are going to download the tesseract OCR and you will install it, you will get a folder like tesseract OCR, and in that folder there is a exe file, and you have to give the path of that exe file in your environment variable path. Okay, and once you have that, then when you will open your okay, let me first kill this, or let's open another terminal. So when you will open your terminal and you will just type path here, then you will let's take a command prompt. So when you will open your command prompt and you will type path here, you will see that tesseract OCR path is there in the path. Okay, so once you have that, it means you are good to go. In that way, now if you do pip install pytesseract, you are able to go forward with the tesseract image extraction, right? After that, actually you just have these 2 steps. Okay, so what you just do is you do image.open, and you just pass the bytes IO object, which is having the bytes data in it. And when you do image to string, this is just giving you so whatever text is written in the image, that text is going to be extracted from the image and it's going to be placed into a string, and that string will be collected in this extract text variable. Okay, then it's pretty straightforward. So but just remember to install the tesseract correctly and setting up the path, and once you have done that, then it's all good to go for you. Okay, now Now, the last but not the least, but the really important modality, which is video. But you guys might have already guessed that what we did with the audio. So you saw that for image, we are just taking the image, we are using PyTesseract image to string, and we are converting the text in the image to as a string, right? That is exactly what we are doing in the video. But we are doing it with every single frame, and we are just concatenating all the text found together, you know. So if the extension is video, we are again saving the video into a temporary video.mp4 file. And this is a very boilerplate video capture, cap is open. It's a very boilerplate code for OpenCV, guys. You can Google this code anywhere, you will find it. This is doing just nothing. This is just processing the video frame by frame. Okay. So when you start this while true loop, it is just reading all the frames. So this cap.read will read every single frame from the video, and then for every single frame it is doing image to string. Whatever image characters have been received, it is just concatenating them in the previously extracted text. And finally, when everything, you don't have to worry about the comment out thing. Finally, when the entire frame, all the frames are processed, that means the return variable is having nothing in it. We will break, we will release our video, we will destroy all the windows that have been created. And finally, it basically means that extracted text variable is now having the correct data, and all the modalities have been processed. So we will just return extracted text dot strip, which is just going to remove all the white space character from the beginning and end. Okay. So this is a very detailed handle input function, guys. I hope you guys have now understood this function. I hope it is a bit more clear to you. Now, once you have handled your input and you have got your extracted text, now it is time to actually feed it to an AI model, right? So let's see how we are going to do about that. So first thing first, we have our main. Let's go back to our main function and let's try to complete our main function first. So there were two things I told you, right? First thing was we were creating a model for our audio. And I told you that we will be having that model in our main function, and it will just pass it into our handle input function. So this is the code for actually creating the audio model. So this tokenizer is the wave to vec tokenizer, and the model is obviously wave to vec to model. Okay, but there is another model that we need. Okay, and that model is actually the model for Google Flan that we are going to actually use in prediction. So let's create that model also here. So I'm just going to copy this code and paste it here. So we are using a Flan model, and we are using from pre-trained Google Flan. Now you might say that I did copy the Facebook wave to vec2 model here, but I didn't copy the Google Flan model. So that was my bad. And I will quickly do that as well. I will quickly copy the Google Flan model also. And again, guys, just like I was showing you the Hugging Face model in the Hugging Face, I was showing you the wave to vec2 model in the Hugging Face website. Similarly, you can go ahead and you can just type Google Flan Hugging Face model download, and you will be able to get the same page, and you can just download all these files from the files and versions. Okay, so now we have got both. We have got our audio model, we have got our Flan model. Okay, and one thing I forgot to tell you guys, that when you are using PyTesseract, you also have to set up the path in the environment variables, but sometimes it doesn't take the path from your environment variables, the tesseract.exe path. In that case, what you can do is you can set up a variable something like this, which is pytesseract.pytesseract.tesseract_cmd, and this is the path of your tesseract.exe file. But this is in case it doesn't work for your environment variable. If it is working for your environment variables with your environment variable, you might not need this line, but if it doesn't work, then you might need it, right? So now we have got our handle input function. We also have got our handle input function. We have also got our models ready now. What do we not have? We don't actually have a function to trigger when we actually upload a file. For example, in this case guys, you can see when the file uploader asks us to choose a file, it is just checking that the uploaded file is not none, then it is just checking the extension and it's printing the extension, right? Correct? What it is not doing is the rest of the it's not doing the rest of the things, right? That for example, it should actually upload the file, it should actually call the handle input function. That part it's not doing, right? So what I'm going to do is I'm going to just simply add a button, and on the click of that button there is going to be an upload function that will be called. Okay, so what will happen here, that I'm going to write here, there is going to be a button, and let's call this button upload, and on the click of this button is going to be an upload function called upload function. Okay, now this upload function we have to create somewhere, right? Okay, so let's create this upload function on top of the main function. Okay, and I'm going to provide this upload function some arguments. Okay, because whenever you will upload a file, you need few things to know about the file. First, the bytes of the file, which is the uploaded file itself. Second, the extension of the file, if it's audio, video, etc, etc. Next thing, we need to actually use extracted text from the from the input, and we want to generate some AI inferences over it, right? So for that we need the flan, model and tokenizer. And this tokenizer and model is for the audio, which we are going to pass down in our handle input function for audio recognition. Again, I'm sorry about the naming guys, but I don't want to change it for change it now, but you can obviously assume that this tokenizer and model is actually not something generic, it's basically for your wave 2 vec 2, so you just are using it for your audio. Okay, let's create the upload function now. So again, I'm going to copy paste the upload function that I have previously written, but don't worry about it, because again I'm going to explain you the entire function. Okay, so this is your upload function. Now what this upload function is saying is, if the uploaded file is none or the extension is unknown, right? That means it's either the file is not uploaded or we don't know the extension of the file. That means it's not one of the list of extensions we are processing. Then it means that we don't know the file. So just upload the file first, or basically we don't know the extension, right? But in that case, if the error handling is we don't go into that if statement, then we just go to the else statement where it says get me the value of the uploaded file. So that becomes your data. Okay, now if you remember the handle input function, that was taking four things. It was taking the bytes data, extension of the file, it was taking the audio tokenizer model or audio tokenizer and audio processing model, which was the wave 2 vec 2 model that we have passed in that upload function here. But this parsed data is nothing but the extracted text. So we are returning the extracted text, right? This is that data. Once we have the parsed data, we are setting that into a session state. Because remember guys, this is a chat bot. We also want to see the conversation happening between the two entities. So we need to have this parsed data stored in a session. Why? Because we need to make sure that we want to display it somewhere. Correct? So that's why we are storing it in a session, and we will also be storing it in a conversation. Okay. So now we have the parsed data. So what we want to know about that data, it becomes our prompt template. Okay. For example, you can say to your model something like this is the image of let's remember what Google Gemini was doing, right? That this is the image of some ideas to make some arts and crafts ideas, right? And some items were placed on the table. So that's why the prompt could now become give me some art ideas on the basis of this. But our prompt is very simple. We are just asking that whatever is there in the image, whatever text is there in the image, just give me 2 sentences in English about that. That's it. That becomes our prompt template. Okay. So whatever input you are going to import, the bot is going to create 2 sentences, generate 2 sentences and give it to you. This is simply that. That's your template. Then you just use your FLAN tokenizer. You give it its parsed data. You give it the tensors, padding, truncation. This is very typical for your FLAN model. And so this is FLAN tokenizer and FLAN model.generate. So let me just take this code and put it here. So remember guys that we are using a FLAN model, right? So in a FLAN model, you can use FLAN tokenizer and FLAN model.generate to actually give the input and you generate some output out of it, right? But there are many models. For example, you might not want to use FLAN model. You might want to use an OpenAI model. So in that case, what you can do is you can create a LLM chain. And here you can see LLM is equals to local LLM, right? I have commented out this code, but you can actually change this local LLM to OpenAI. Something like that, right? So no, there is no one stopping you. But just for simplicity, I have used the Google FLAN model, where you can obviously use the similar code which is commented out, and you can just change the code to use an OpenAI model if you want to. Correct. So now that you have your sequences, you can just use batch decode to get the decoded output. Okay, and in case you were using some LLM model, you would have been using chain.run, pass the input, and that output would have been your output. Whatever, you can use any type of model. Finally, the predict state, that means we have our upload state where we are uploading data, we have our predict state where we are prediction, where we are predicting, we are answering. So that becomes your decoded 0. That means your first ever prediction, or the best prediction that you have, right? And finally, what we are also doing is that, so if you want to display the uploaded data and the predicted data separately, you can use it with the different session state. But for us, we also want to display this in a conversation manner, like one box after the other. So actually, if you don't do this, if you don't create the predict state and the upload state, it would still work for you, because we are creating a conversation session variable where we are always appending the question, which is your parse data, and the answer, which is your decoded 0. So you will understand this, how we are actually using this session state conversation variable, and this will help you have more idea about how I am able to use it to display the UI of our chatbot. Okay. Just remember that the upload state and the preview state that we did before, we are not using that now because we don't want to display the output anywhere other than the conversation that's happening. And so yeah, you don't need it. You just need one conversation variable to just have both the conversation from the bot side, also from the user side, where we are pretending that the first conversation will always be from the user and the second will be always from the bot. So in that reason, the basically the even conversation, the 0 to 4 conversation will be from the user, and the odd conversation, the odd index of conversation, which is 1, 3, 5, will be from the bot. Okay, and once you have that logic in mind, you can just use this conversation variable to actually display your output. So I have written a display function also, and that is what is being called after the upload function. So the display function is doing the exact same thing I told you. It is taking the index of the message and the message itself. If the message is even, it's it's a user message. If the message is odd, it's a bot message. So it's just displaying the message, right? So that's why I deleted those other session state, upload state and predict state from the code, because we are not going to use it. We only are going to use the conversation state, which is a list of all the conversations. Okay. So now what we did, we created a upload function, which is actually uploading our file. doing the predictions on the file, giving us the output, posting the output in the conversation session state, and finally displaying it, right? And this upload function is now being called on this upload button. But there is one thing we didn't do. So we say that the session state conversation is going to have the list of conversation from the user in the bot. But there is nowhere in the code we initialized it. And where we are going to initialize it? We will initialize it in our main function, because if this conversation variable is not in the session state itself, we will never be able to update it or add more conversations into it, right? Am I right? Right. So what we are going to do here is we are going to just simply declare somewhere in the main function. We will just check if the conversation is present in the session state or not. If it's not present, then make it present with an empty list. Because once you upload the file, obviously the new conversations are going to be added, right? But we just need to instantiate it with an empty list. Let's save this code, guys, and let's have a quick look. So we have all our models, PyTesseract is also set, blah blah blah, and we have got our upload function also. I think we should give it a go. We should see how it works, and if there are any issues, obviously we are going to fix them. So but for now, let's run this. Okay, so seems to be running now. Takes some time to run. Obviously this is my local PC, guys. It's my local laptop, so it's not that powerful to run these type of things. However, they do still run, and takes some time to load, but then obviously at the end it runs pretty okay. But if you have your own environment, you can obviously use Google Colab to run these type of projects. And for me, I mostly use Kaggle, if you have seen my Kaggle videos. But there you go, guys. You can see that it's now able to accept our file. Oh, wow, that looks cool. So let's give it a text file. You know what? Let me first show you what text file we have. Okay, let me first show you what text file we have, so that we can, compare our output. So this is the folder, and you can see that this hello.txt is a simple text file, and it is just having a question, what is Google? Okay, so let me browse the file here, and let me just click on hello.txt, and you can see that once I selected hello.txt, it starts to run. The first thing it's going to do, it's going to determine the extension of the file. And once it determines the extension of the file, it is also going to give me the extracted text, and then it is going to parse that output. And you can see, guys, how beautiful that was it. It took the text input and it gave me an answer. But now you guys might say, no, anybody can do that. Anyone can take a text input and give me an output. Show me something different. So I'm going to show you something different. Let's not take a text input this time. Let's take a image input. Okay, let's take it one by one. Let's first take an image now. So you can see that this image is basically a meme. So this is a famous Indian cricketer, and he is basically asking, what is Gemini? You know what, I'm also curious. Let's browse that here. So this is my JPEG file, and you can see as soon as I upload it, it's now churning its brain to get the extension and then getting the output out of it. Obviously image will take some extra time, guys, because we are using PyTesseract. Obviously the text is much quicker, but I think it gave us something. So it says, what is Gemini? So apparently, as per Google Plan, the city is located in Gemini on the right side of the road. The station is the center of Gemini, and the Himalaya in this corner of Gemini is called an ocean. So I don't know why it's calling Gemini a city or a location, because clearly Google Plan is not aware about Google Gemini. So Google Plan needs to update its hyper parameters that it has been trained on. But did you see the magic, guys? This same chatbot is aware of the type of input we are giving it. It knows it we are giving it image, text, audio, video, and it is able to give us the output. But I didn't complete the demo yet because I still have to show you two more things. One is the video and one is the audio. Let me first show you the video first, and let me get that here. Okay, so this is the video, guys. Basically, this is a video which I created with two frames, and one frame is having a what is and another frame is asking quantum computer. So if I just run this video, it's pretty quick. It says what is a quantum computer, right? And what we are going to do, we are going to take these two frames, extract the text out of it, merge the text, create a singular question and ask it to our bot. And let's do that. This is video. And again, you can see our bot is running pretty fast, running, swimming, cycling, doing all those things. And then once it does, is that it is going to use OpenCV to run each frame, take PyTesseract to take the text out of each frame, and then finally append that text, concatenate it together, give it to our FLAN model and give us a result. And that result says, what is a quantum computer? What is a quantum computer? Quantum is the official language of Canada, the name of the common title of Canadian, the Canadian language, blah blah blah, continuity of the population of Canada. So obviously you can see, guys, that the output of Google FLAN is not as accurate as it should be, but it is probably it is being trained on some hyperparameters which were so old that it has not been trained on something like new terms of quantum computer. That's why it is giving us some old results. But you can see that if you just change the model here, if I would have been using an OpenAI model, if I would have been using a really better model than Google FLAN, then I might have gotten really great results. But it's just that I'm using Google FLAN because it's a small model and easy to run on a local computer. I'm getting these results. But nonetheless, guys, you can see that my chatbot is not so bad because it is taking the video input and it is giving me an answer. So I would say, well done. But we still have one last thing left, and that's the audio. Okay, so what I did, guys, for the audio, I actually went to a free website to convert speech to text, and my audio was basically, your call is important to us. It was a SOS, it was a customer care prompt basically. So if I try to basically run that audio here, I don't know if you guys will be able to hear it, but let's try it. Let's try it.
Your call is very important to us.
Okay, so I'm not sure if you guys heard it, but it basically says your call is very important to us. So what I'm going to do is I'm going to upload this audio file, and let's see how is it going to break down this file and how is it going to give us the correct audio transcription as well, and along with the correct prediction. So that's the last of the modality, guys. Image, audio, video, text. We have done all of them, and that too on a local computer with no GPU and no cost model. So we didn't even use OpenAI because it would have costed us. But if you want to just use it as a POC or for any other thing, you can use free models. Let's scroll down. And you can see that it correctly recognizes the speech. First of all, your call is very important to us. So that's why Wave 2 Vec 2 is a very accurate audio transcription model. But, so to describe two sentences, where is your call, title, daily package, the read this out of the event, blah, blah, blah. So obviously, guys, surprise political schedule. So I don't know where it is getting these details from, but it's definitely taking it from some reference, and then it is just quoting it here. And obviously whenever you will run Google FLAN model, guys, you will be able to see different results because it is trained on some hyper parameters which are quite old, and that's why it's not giving you accurate results. But the purpose of this chatbot was to create a bot that can accept any type of input and is able to give you the output that you want to see. However, the model is not that accurate. I must say that if you have just used a different model with the exact same code that I have written, you would be able to achieve some really great results. Do we want to compare this model with the Gemini one? Well, I'm a bit apprehensive about it, but I will say, well, let's do it. Okay, let's just take one simple image and let's feed it to Bard and let's see what Bard has to, say about it. So I'm just going to click on the image and I'm going to take that. Let's take PewDiePie's image. Let's see how they react to it. So describe it. Okay. So PewDiePie is saying this zodiac sign just with Gemini people. Well, I also want to know about that. Sorry, I can't help with the images of people yet. Oh, well. So I guess my model is much better than Bard now because we are working with images and we are able to give you guys results. But I think if you just give Bard any other image with no person in it, definitely it is going to work for you. However, maybe they haven't yet enabled the people images in Gemini, in Bard yet. But don't worry about it, guys. This code is entirely available on GitHub. I will post the links of whatever model I have used. I will post the links for Tesseract. I will post the link for my GitHub as well. But that was a video, guys. How interesting was it to just create our own Gemini-like chatbot and get some AI out of it, some generative AI out of it, giving it any input we want, any image, any video, any audio, and just getting some nice output out of it and see how it works in a proper chat-like form. So I hope you guys enjoyed this video, guys. I hope you learned something from it. If you did like this video, guys, then please do not forget to like this video, share this video with your friends. If you have any questions, comments, suggestions for me, please do write down in the comment section below, guys. I would be really happy to really happy to read them and go through them. And if you have not yet subscribed to my channel, guys, so please do subscribe to my channel and hit the bell icon for future notifications of more such programming and coding related videos. I know this video has been so long, but it had a lot of steps that needed some explanation. But I hope now you guys know about it and you are ready to create your own Gemini-like bot which supports multimodality. So thank you so much for watching. I'll see you guys in the next video. Until then, take care and bye bye.